All right, I'm really excited to show this new addition that will be coming to DragonOS. I've talked about it. Actually, I mentioned it during DEF CON, during the video that I submitted and was at least played during that time frame. This is the new Signal Server GUI. This is going to kind of take over or just enhance what's already available in DragonOS to control Signal Server. And so the probably a little biased, the country or the work that the individual that put this together has done is really extensive, very impressive, and is available publicly, and pretty soon it'll just be included by default in DragonOS. So the images I've got up here are for some testing that was being done with this. On the left I've got a RF propagation plot from station to station and some analysis that goes along with it, and then over on the right is a single station plot with the RF propagation visualization there. Both of these are shown over Google Maps, but the goal would be this works in DragonOS with CZM, whether that's a photon map or some other things that I've shown in the past. So let's jump right into this. I'm going to show how to add this project here. I've got the page pulled up, the Signal Server GUI. I'm going to show how it can be added right now to DragonOS while I continue to work on the next release or maybe an update. But you can see it's a GUI that provides a simple and intuitive interface to manage, and the key piece of this is the many configuration options available within Signal Server. So there's a lot of options that are available to really fine-tune your RF propagation analysis that weren't previously selectable in the other interface that I've shown in the past. So I think this is huge. Allows you to create antennas, allows you to create stations, plots, and the amount of output that comes out, whether it's text files, JSON files, is really extensive. So, encourage you to look through the work and the code that the individual has done. It's very extensive. Provides a lot of options here. So let's do a clone of this into DragonOS, just as if I was going to install it. Usually I stick things in user source so that it survives the technique that I use to make the DVD or the ISO that everyone can then install. So in this case we'll do a sudo git clone down this repository. Now this repository does come with some elevation data, but I'm not going to use it in the examples here I do. So we'll change into the Signal Server GUI. We'll do a sudo nano config on the ini file, and what we need to change is the path to where Signal Server is on DragonOS, which in this case it's in Signal Server, just like you see there. Otherwise, these options, if you install it in something else or you want to stick with the default directories, you shouldn't have to change these. I'm just going to change these two for DragonOS. So we'll say the elevation data directory. We'll use the elevation data that we already have in user source SDF. Save that file. We need to do a sudo pip3 install-r on the requirements. The txt file, I've already did this before the video just to speed this up, but you'll notice there'll be a few additional packages that are needed. Let's see, besides that, we're pretty much set. This has its own built-in SQL database here, or a database I should say. So we'll do a sudo python 3-m signal server _ GUI. I'll serve up the files here on port 8080 by default. If we open this up, we see we've got the home page here, which gives a little bit of history and a little bit about Signal Server itself. Also mentions Splat, which is very significant. That's where, best of my knowledge, things kind of started, and then Signal Server built on top of that. We can see how quickly we can get started here and kind of the steps that we're going to go through, or I'm going to quickly show here. and then the output files that are generated depending on what type of plot we do. The other thing too is, in case you need this as a reference, if we start the Apache 2, you can still access the older or the other interface here in order to get the Latin long that we're going to be using. So that's still there. The other thing too, it's got a good reference down here on the About page. This is the other interface. The HGT files gives you a good link to view finderpanoramas.org, where you can get more data that can be set up and converted for Signal Server. Alright, so we have a look at, we got 5 default antennas. Quickly, if you want to add a new one, you click New, give it a name. You need to feed it an ANT file, which is I think it's version 3, I think, is the ANT file that this web interface, the Signal Server GUI, will convert to the correct format for Signal Server. I'll just show you an example. If you look in the actual Signal Server GUI folder that you downloaded in data antennas, let's just pick like corner. There's an ANT file there. If I select that and I can set the gain for it, threshold, hit submit, that will be converted to the correct files for Signal Server. In this case though, we'll just go with the generic dipole. And I know I'm going through this fast, but hopefully you can appreciate the amount of work that's went into the web interface here, the ability to use sliders or text, actual text entry here. We'll add some gain to this antenna, click Save, come over to Stations, and we'll create 2 stations, and I'm going to use that Latin long that I got from the other page because I know there is elevation data there, and I had previously typed these numbers in. That's why they're coming up there. We'll go with 100 on the station 1 height, and the reason why is because I know this data is out in Colorado near a mountain, so I just want to kind of raise it up so you can get a better idea of what's going on here. We'll create another station. We'll use roughly the same location, change the longitude a little bit, and I'll raise this up even higher. You can see the other settings that can be set. I'm not going to adjust the antenna characteristics at that station as far as its rotation, down tilt, and direction, but you can now do that. That was not previously selectable before. Now we'll get into the really interesting part here, which is the plots itself. We'll create one plot with no point-to-point analysis. You can see all these things are now selectable to really fine-tune your propagation analysis. I'll just go with 146 megahertz. You got 20 megahertz through 100 gigahertz line of sight. After 20, you can change the opacity on the image that will be pumped out into the KMZ, but we can also change that in Google Maps itself. Go with 100 watts radiated power. I'm not going to touch ground clutter or a lot of these other settings, but you can see if you need to change your terrain code, the dielectric or conductivity, climate code can be changed. Some of these are optional, some are mandatory. You can kind of read through underneath to find out more information about that. We'll go with probably 30 miles on the radius. Resolution, you can do 1200 or below. If you want to hit 3600, you need HD elevation data, which I don't currently have set up in the directory I pointed it to just a second ago, so we'll stick with 1200. We'll do ITM on the propagation model, which is default Langley-Rice plot. Antenna ID, we'll do a dipole, and I won't put a second station here because we're just going to do a single single station plot. Alright, so we've got our plot set up. You can always delete. You can even search through stations, antennas, and plots. All this has been built in here, but we need to we'll click Files, and what will happen is behind the scenes you can see that what we put in is was being passed to Signal Server. Now all this custom additional work here, outputting this in the format that you see on the screen, the files directory, all the KMZ work, all that has been additional. You can see we got some image files that are outputted. The SCF file is a file that maps colors, probably like red, blue, green, the color format to power levels, so you can kind of understand what these colors actually mean. And that's the other thing I guess I should point out is the receiver height and the gain that we messed with on the antenna. That also affects this, because theoretically we've got our transmitter, and then best of my understanding is these colors out here can also be adjusted depending on how far the receiver anywhere in here is sitting and its gain, so that can be taken into account as well. But let's grab our KMZ file and we'll download this, and for the purposes of the demonstration we'll just go with Google Earth. Once we got Google Earth opened, and I should also point out I'm recording this over a stream from the computer on the network, so might be a little lag there. So we'll import that KML file that we just created. We'll give it a second. It's loading, and then we'll see how kind of similar to in the past I've shown, but now we've got the addition of the pin that's there, the description, fully like interactive here as far as the map goes. Going in and out, we can get a little better resolution since we set it at 1200. Now this opacity that could have been set in the beginning can adjust here, or we can somewhere in here. I always forget. There we go. So we can adjust opacity there as well, or when we initially build the file. Alright, so let's drop this off the map for a second, and we'll come back, and what we're going to do now is we'll create another plot. We'll name it Test Station Plot 2. We're going to do point-to-point analysis on this. I'll leave everything else as default up top here, except for we'll go with 146 megahertz again. We'll do that 100 watts radiated power, which again, this is really just point-to-point. So let's see. ITM, go with a dipole again. And most of these I'm just setting to have something set there. If you had additional settings on the stations and the antenna rotation and stuff, that very well could affect the RF propagation analysis from point to point. So we'll submit this. We'll take another look. So now we have our station to station plot. Click Files to go ahead and generate that. So now we can see we've got still the overall plot of that initial station 1, but now if we got point to point, we get our point to point analysis. We can download that report into a text file, but we can also look at the files directory to see now we have access to all this other information, a profile, a JSON, Again, the image is the .scf for that color mapping and power levels. But we'll take a look at the KMZ file here because I think this is really impressive. We'll import that plot too. And so now we can see where that KMZ file gives us access to all the obstructions that are in it and other various things that the developer has put in here. Like we can go straight to test station 1. And when we go down here, we're going to get an analysis that'll pop out on the right hand side that'll allow us to see what the terrain looks like, the profile of the terrain, how many miles over the distance here, the line of sight path, which all lines up. A lot of work has been put into making sure this all makes sense. We've got the transmitter site, receiver site. You can see there's a little over 5 miles between it. The propagation model, some information about that. We've got receiver gain, and then the summary of the link between the two locations. So you get your free space path loss, some attenuation, other information that's going to come out. Sometimes you may notice the Longley-Rice error model number, and so if you have some parameters out of range, it's just, you should use, well, really with any of this, it's a best guesstimate, I guess you'd say, on this information, because the RF propagation can change on various different conditions. But now we can see we've got what obstacles are in between, and again, this is just a plot that I did over a mountainous area. Ideally, I'd probably want to do it over back in this area here. But we can see we've got our clear line of sight, and if you zoom in close enough, you can see that the pin sits the accurate distance off the ground, and you get that shadowing underneath to see and visualize the obstruction, or the obstructed path, I should say. Zoom out, we can see we've got our other station here that was sitting higher off the ground. If you want to do any of the line of sight, just focus on that, the clear line of sight or the obstructed, you could click on those. Again, get that information that pops out on the side. So I think that's a huge addition. Really impressive, the amount of information you can get out of this. I guess the last thing I could show here real quick, if we take a look at the plots, and we can see, because sometimes you might just want a line of sight plot on just the station. So if you come down here to propagation model and we change this to line of sight, you'll see how the plot changes a little bit here. So if we regenerate that first plot, now we can see, based on the information we fed in there and the elevation, where our line of sight is at based on that transmitter's location and the elevation that's around it. So I guess the last thing is the config file. You can just verify the paths are set, so convert and Signal Server is already in DragonOS, so as long as you change like that path I showed, and then you could see the other path, that's pointing to the elevation data, then you're pretty much all set up, and you can at least follow along with what I've shown here, and then feel free to jump in and do even some more complicated settings, change some other characteristics, really fine-tune your RF propagation analysis, and then yeah, please, if you can, provide some feedback, and yeah, so hopefully enjoy and get this set up on your end. All right, thank you.